All right, so let's do part three here of using the chain rule. And the first problem we have here is f of x is equal to 5 to the power of the root of x, or the square root of x. All right, so this one's a little different. When we have a constant to the power of a function, we have this rule here. So we're going to have b, which is the constant, a function f of x to the power, right, times ln b times the derivative of that function. A lot of times you might not see this part in a book. You might just see this part here. And so what I like to do is always add that last part here, because you might get something that is um not just x. You might get something that's like x squared plus x, or x squared plus 2. You might get something else to the power there. So I always like to add this last part to that rule. All right, so let's go ahead and begin. We're going to go ahead and follow that rule. So we're just going to have 5, the root of x, very similar to the exponential function rule, times ln 5, and then times the derivative of the root of x. And this is where the chain rule comes in. We're going to go ahead and rewrite this to go back to the eraser. I have no idea what's going on here. Okay, so let's go ahead and rewrite this. The 5 to the power of x times ln 5. And then this is where the power rule, or the chain rule, I should say. Did I say power rule last time? I meant to say chain rule if I had said power rule. But anyways, it's going to be half when we rewrite square root of x. That's the x to the power of half. So that's going to be negative half here. And that is it. You could, if you want, have your and of course you're going to do the inner function was x, but the derivative of x is just 1, so that's why we're not going to write the derivative there. You could write that right side here, the one with the half, as times 1 over 2x half if you want, but I like to just keep it like this. I like to just have my answer like this. Again, your professor might want it differently, but this is the way that I like it. After I finish the derivatives, I am done. Sometimes I simplify. For example, this one, I will have to rationalize the bottom, because over here you're going to have a root. So you're going to have to put that root up above and whatnot. But we're going to keep it like this. And that was our final answer. All right, so here is our second example. This is where we use the exponential rule here. So the first one stays the same, or we would just rewrite the function, I should say. And we're going to go ahead and just simply take the derivative of tan x. And the derivative of tan x you should memorize, and that is secant squared x. And that's it. That's how easy this one was. That's why what I like to do for examples that involve the e here, I like to write the rule as e to the power of f of x times the derivative of whatever that exponent is, if it's a function there. You just take the derivative of that function, and then you're done. So this is the derivative of e. And of course, we did it here, so that is our final answer for the second problem. All right, so here's our third problem. I'm going to have an extra one here for this video. These were pretty short problems. What we have here is x plus 1 over x to the 5th power. So again, chain rule. So we're going to go ahead and put that 5 on the outside of the parentheses, x plus 1 over x. And we always subtract 1 from the exponent when we derive that constant there. And then we're going to multiply by the derivative of the inner function, which is x plus 1 over x. So we're just going to have to take the derivative of each of these terms. So the derivative of x, so let's use distributive property here so you can see a little better. The derivative of x is just 1, so we're going to go ahead and rewrite this function here. So we're just going to write 1. And then over here, the derivative of 1 over x may not be apparent initially, but what you could do is take the inverse. So you'll have x to the negative 1. You take the derivative of that. of course, you multiply that -1 on the outside, and you have to subtract 1 to the exponent, which is -1. So -1 minus 1 is -2. And so you'll have minus x to the power of -2, which in other words, this could be your final answer. But if you don't want negative exponents, you could rewrite it as 5 times x plus 1 over x to the 4th power times 1 minus 1 over x squared. And you can leave it like this as well. Okay, so here's a bit of a very long problem here. This one's a little tricky. So what I want to do here, I can see that I can use the chain rule. So I know that the exponent of this function is going to be half, just, how we see it here. It's going to be half. But what I want to do to make it easier for you guys to see is write what f of x is going to be and what g of x is going to be. Because we're going to have to use the quotient rule in this one because we have two functions being divided. So we're going to have to use the quotient rule, and it'll be easier if we just rewrite what f of x and g of x is going to be, so that when we are actually using the quotient rule, we know which one goes where. So f of x is going to be my numerator, which is 1 plus sine x, and my g of x is going to be the bottom one, the denominator, 1 plus cosine x. All right, so let's start off with using the chain rule. So that's just going to be half. So again, if I rewrite it, I don't really want to, but let's rewrite it. This function really is 1 plus sine x over 1 plus cosine x, and then half. When we rewrite the radical symbol here, it's a square root, so that's why you see 2 in the denominator of that exponent there. All right, so now we just use chain rule, so that's going to be half, and then rewrite that inner function, 1 plus sine x, 1 plus cosine x, and then this is going to be negative half. And then we're done with the first part. And the second part, of course, is going to be taking the derivative. Let me write it up here. Taking the derivative of the inner function, which is the 1 plus sine x over 1 plus cosine x. Okay, so now we have to use the quotient rule. And the quotient rule here, I'm going to write it in blue, is it always starts off with g of x, and you're always taking the derivative of that second one next to it. So that's going to be f of x, or we can just say f prime of x, minus, and then rewrite your f of x, and then you rewrite g of x, but it's primed. And then over g of x squared. So that is the rule for quotient rule. All right, so as we can see here, we have, well, we're going to start off with g of x. So we have the f of x and the g of x. We'll start off with writing the g of x. That's going to be 1 plus, I might need a lot more space. Let's see how small I can write this. Let me move this over. We'll start off with g of x, so that's 1 plus cosine x. We're not taking the derivative of that one, taking the derivative of the f of x. So I'm going to write 1 plus sine x prime minus, then just rewrite 1 plus sine x. And then you take the derivative of g of x, which is 1 plus cosine x, and then prime, and then over the 1 plus cosine x, which is the g of x, of course. And then we just have to simplify. So I'm going to rewrite this first part a little later on. I'm going to continue with the right side here. So there's nothing with the first 1 plus cosine x here. So we're just going to rewrite that. And now we're going to take the derivative of this one here. So that's just going to be cosine x. So, of course, the derivative of 1 is 0, and the derivative of sine x inside that parentheses is just cosine x. Then minus, rewrite 1 plus sine x, and the derivative of 1 plus cosine x, of course, the derivative of 1 again is 0, and the derivative of cosine x is negative sine x. Okay, and that's going to be over 1 plus cosine x squared. All right, now we're going to use the distributive property. We're going to move this a little down. We're going to use the distributive property to distribute that cosine x into this parentheses. And it's what I teach my 7th graders to do, is always draw the arrows. You're going to get cosine squared x. This isn't 7th grade, but when we're doing simplifying linear equations, sometimes we have to use distributive property, and so I show them how to use distributive property with the arrows sometimes. So cosine x times, they're not doing calculus. Cosine x times cosine x is cosine squared x, and then cosine x times 1 is just plus cosine x. And then over here, I'm going to keep the minus sign on the outside. And then I'm just going to do the sine x. So this part here, I'm going to do right now. Keep the minus sign outside right now. This is simple. It's just going to be negative sine x times sine x, which is negative sine squared x. And then the negative sine x times positive 1, which is just minus sine x. And then close out the parentheses. Put it over 1 plus cosine x squared. Don't forget that bottom denominator. A lot of people always forget about putting the denominator there. They always forget, and then they get points off. Okay, move this down a little bit. Now we can distribute that negative to the right side parentheses. So over here, we're distributing, basically just changing the signs on the right. But let's write the left side first. That's cosine squared x plus cosine x. That's going to be plus sine squared x plus sine x. Okay, over 1 plus cosine x squared. Now what we could see here, I'm going to highlight this one. What we could see here is a trigonometric identity. So what that is, the two terms I just highlighted was, whoops, got to change it back. The two terms I just highlighted were sine squared x and cosine squared x. So this sine squared x plus cosine squared x is actually equal to 1. So we're going to change that to 1. So initially what's happening here is they're disappearing. We're just going to add a 1 there. So I'm going to go ahead and say cosine x plus sine x plus 1, because that is the trigonometric identity here. So you want to write that down somewhere in a sheet of paper where you have your identities. Okay, and then it's over the 1 plus cosine x squared. There's nothing else to do, but what you don't want to forget also again is that you actually had another term here, which is the half. Let's write this from left to right, or from right to left. You have 1 plus sine x, the inner function, 1 plus sine x over 1 plus cosine x, and then you had your half, and this is just how I would probably just leave it. You could just shift over this term, you could shift over this term to the bottom of this half, so you could have, let's write the 2 first, and then the parentheses, 1 plus sine x, 1 plus cosine x, and then half, and then you have that over 1, and then you have that that right side as cosine x plus sine x plus 1 over the 1 plus cosine x squared. You could leave it like that. You can simplify further, but I like to just keep it like I have it here on the top or the bottom without the negative exponent. So that is your final answer.